Hello guys. So in our last lesson, we were dealing with factoring polynomials that looked somewhat like this one, where there was no coefficient right here in front of the x squared. So we assumed that it was a 1. Then when you factored it, you just had to find a set of numbers that multiplied to give you 10, or in this case, negative 10, and added to give you a negative 3. And when you did that, you would have found that it would have been a negative 5 and a plus 2 that would have satisfied this. And so therefore, your factoring was x minus 5 and x plus 2. All right, that's what we did last lesson. However, it is not always the case that the x squared doesn't have a coefficient. Sometimes you might have a situation where instead your polynomial looks something like this: 4x squared plus 16x plus 12. We have to do something different in the factoring, but it's still a lot of the same steps. Just have an extra little step to do. And so we're going to get to that today. Before I take you to factoring, I want you to practice multiplying binomials, because I think when we practice multiplying binomials, we understand the factoring side of things a little bit easier. So here's the example I'm going to give you today. What if you multiplied 3 times x plus 2 times x minus 3? Okay, well in doing this, what you would want to do is multiply the binomials first. Then you could multiply the 3 next. So let's first look at multiplying the binomials. You're going to get x squared plus 2x minus 3x minus 6. And then you're going to want to times that by 3. Well, if you notice right here, we've got like terms that we have to combine. So let's simplify again. 3 times x squared minus x minus 6. And then now you're ready to multiply by that 3. Distribute it to each one, and you would get 3x squared minus 3x minus 18. Okay, so this is going forward. Let me show you another example of a multiplication of binomials that would get us to a polynomial that has a coefficient on that x squared. Something like this. How about 2x plus 1 times 3x minus 2? Well, when you do this, you would end up with 6x squared minus 4x plus 3x minus 2. Well, you've got your like terms here that need to combine, and so you would end up with 6x squared minus x minus 2. Those are some examples of multiplying binomials, and you would get a polynomial with a coefficient in front of your x squared. Well, now that you see how that comes about, let's now see what we're going to do when we have a polynomial that has a coefficient on the x that isn't a 1, and how we factor that to find the binomials. All right, first example. 4x squared plus 16x plus 15. Okay. So you're going to want to factor this using those circle problem skills first. The only difference is that in the past, we just said that you had to find 2 numbers that multiplied to give you this number. Well, that's because we assumed that that number was a 1, and anything times 1 is just itself. But now that this is a 4 instead of a 1, we have to multiply them together to find out what goes here. So 4 times 15 would be 60. We then take this coefficient and put that down in the bottom for what we're trying to find to add to. So now when you're looking for what multiplies to give you 60 and adds to give you 16, you're going to find that it is 6 and 10 that work. So see here, the only difference is that we now have to multiply these two numbers in order to get what goes in the top. Okay, so now that we have this, we've got to do a new step. What you do is you start to rewrite your polynomial. So we're going to write 4x squared plus. Now we've got to ask ourselves, what are we adding to get 16? Well, it's a 6x and a 10x that will give us the 16. And then you finish with plus 15. Notice that I got this 6 went here, and this 10 went here. That's how I got those numbers. Now, you could have put it the other way as well, but what's going to determine which one you put first, whether you put the 6 or the 10, what's going to determine is our next step. So after you've written this out, you want to look at each of these pairs separate, and you want to find what is it that is a common factor to both of those. If I put my 6x and my 10x in a place where they didn't find a common factor with what was next to it, then I might want to switch them and try that differently. So let's look at 4x squared and 6x. What is a common factor? Well, the 4 and the 6 have a common factor of 2. The x squared and the x have a common factor of x. I would have to multiply the 2x by 2x to get 4x squared, and I'd have to multiply the 2x by a 3 to get the 6x. Now let's look at the 10x plus 15. Well, the common factor that these two terms have is just a 5. I would have to multiply 5 by 2x, and I'd have to multiply 5 by 3 to get 15. Well, if you've set this up right, what you're going to notice right here is that this binomial and this binomial are the same. That means that is one of your binomials that is a factor of your original polynomial. Now, the other factor is made up from this number that was the greatest common factor of the first set and this number that was the greatest common factor of the second set. And so your factors then would be 2x plus 5, just bring that down there and that down here, times 2x plus 3. Just brought that straight down. This is 4x squared plus 16x plus 15 factored. You can multiply those back and prove to yourself that you did it, but I'm not going to take the time today to do it because I want to try one more example here for you. Okay, let's try 6x squared plus 11x plus 3. Okay, so remember, first thing we're going to want to do is use that circle problem technique to factor it. So we've got to multiply 6 and 3 to give us this top number. 6 times 3 is 18, and we're looking for two numbers that multiply to give us 18. We then want to take our center number and put that down here, and that's what we're going to add up to. Well, what two numbers multiply to give you 18 but add to give you 11? Well, if you said 9 and 2, you'd be correct. Our next step then is to rewrite our polynomial. We've got 6x squared plus 9x plus 2x plus 3. Remember, all I did was take these numbers and put them right in here. Okay. Now we have to look at each group and see if we can pull out a common factor. Well, if you notice, we could pull out a common factor between the 6x squared and the 9x squared, but we can't pull out a common factor between the 2x and the 3. So this would be an instance where I would want to switch that 2x and that 9x, because then we could pull out a common factor of both sets. So let's do that. So I want 2x to go there, 9x to go there. I did that on purpose because sometimes you're going to do that and need to switch it. So 6x squared and 2x, the common factor would be 2x that would come out of there. So 2x would get multiplied by 3x to give us 6x squared, and 2x would get multiplied by just a 1 to give us 2x. We'll now look at the other set of two. 9x and 3 have a common factor of 3. And when you multiply 3 times 3x, you'll get 9x. And when you multiply 3 times 1, you'll get 3. So therefore, one of our binomial factors is 3x plus 1. So we can write that down. But our other factor then is going to come from 2x and the 3. And that's what makes up this one right here. Okay? I hope that made sense to you. If not, I'm in the Zoom meeting from 8 a.m. to 11 a.m. on Friday. And then I'll be back in the Zoom meeting probably from 12 to 1:30. Or you can email me to set up a private time. Okay? Your homework is posted on Canvas. I hope you guys have a great weekend. I love you, and I'll see you Monday.